Hi students, in this video we are going to study about lens formula. You know what is lens formula, isn't it? It is 1 by f is equal to 1 by v minus 1 by u. We are going to derive this equation in this video. And before going to lens formula, let us see which are the sign conventions used for a spherical lenses. Now imagine you have a lens of optical center O, and an object is placed in front of the lens and an image is formed on the other side. Now the first sign convention which we use is all distance are measured from the optic center. Center. The second assumption is the distance measured in the direction of light is taken to be positive, while the distance measured in direction opposite to that of the light is taken as negative. So, distance measured in direction of light is positive and distance measured in opposite direction of light is taken as negative. Now height of the object which is upward and perpendicular to principal axis is positive, while the height of the object taken downward perpendicular to principal axis is taken as negative. So third point is height of the object upwards and perpendicular to principal axis is positive, while height of the object downwards and perpendicular to principal axis is taken as negative. So these are the sign conventions used while we are deriving the equations for lens. Now let us see what are the rules used for drawing the images for a convex lens. Concave lens also you will get the similar ray diagrams. First one, when a ray passes parallel to the principal axis, so we have a convex lens, and if a ray is passing parallel to the principal axis, then after refraction what happens? After refraction it passes through the principal focus of the lens. So any ray which is passing through to the lens parallel to the principal axis after refraction gets the ray passes through the principal focus of the lens. Now the second one, a ray which is passing to the lens through the principal focus. Ray enters the lens through focus point, through principal focus. This is the lens. optic center, the ray which enters the lens through principal focus. After refraction, what happens? It passes parallel to the principal axis. So any ray which enters the lens through principal focus after refraction travels parallel to the principal axis. And the third point, the ray which passes through the center of curvature, through the optic center. The optical center. Now if a ray enters through the optical center, then what happens? After refraction also, without deviation in its path, it will continue in the same path. So the ray which enters the lens through optical center after refraction remains undeviated in its path. Now the assumptions which we used for deriving the lens maker's formula, the same assumptions we use while we are deriving the lens formula. The lens formula is the formula which relates image distance to the object distance and focal length, that is 1 by V minus 1 by U is equal to 1 by F. We are going to derive this equation. For that we are using the 4 assumptions that we used for deriving the equation of lens maker's formula, which is all objects are considered to be point objects. Second one, the rays are paraxial, which means parallel rays close to the principal axis, making small angles with the principal axis. The third one, the aperture of the lens is very small, and also we are taking a very thin lens for deriving the equation. Okay, so imagine you have a convex lens. This is a convex lens. Okay, and an object is placed in front of the convex lens beyond the focus. So AB is our object. Now two rays, we are taking two rays for deriving this equation. The ray which is parallel to the principal axis, which means at point M on the first refracting surface of the lens, and after refraction it passes to the focus. Similarly, the second ray which is passing through the optical center without deviation in path, and these two rays meet at the point A dash. So A dash, B dash is our final image. Now U is object distance. Object distance means distance taken from the object to the optical center. V is the image distance from the optical center to the final image, and F, small letter F, is the focal length taken from the optical center to the focus of the lens. Okay, now so U is the object distance, V is the image distance, F is the focal length. This diagram, AB is the object and A dash, B dash is the image. Final image formed, final real image. Okay. Now for deriving this equation, it's very simple. We consider two sets of similar triangles, and using those two sets of similar triangles we formulate the equation. Now the first set of similar triangle which we consider is triangle AOB and triangle A dash B dash. This set. So we are considering the triangle ABO and triangle A dash B dash O. And these two triangles are similar. Okay, so from the figure, triangle ABO, and similar to triangle A dash B dash O. So formulate. So we can write B dash A dash by BA, or AB is equal to B dash O divided by BO. So B dash A dash divided by BA is equal to B dash O divided by BO. The first equation. Okay. Now the next set of triangle, similar triangle which we are going to take is triangle MOF and triangle A dash B dash F. So triangle MOF is similar to the triangle A dash B dash F. So again formulating the equation, we get A dash B dash divided by MO is equal to B dash F divided by OF. This is equation 2. Okay, now if you look in this figure, you can just clear that MO and AB are equal, they are parallel and they are equal. So instead of MO, what we can write? We can write AB. So from the figure, MO is equal to AB. So the above equation becomes A dash B dash divided by AB is equal to B dash F divided by OF. This is equation 3. So left hand side of equation 1 and 2 are same. So comparing equation 1 and 3, we get equation 1 and 3. We get B dash O divided by BO is equal to B dash F divided by OF. Now, our aim is to formulate an equation using U, V and F. Now, if you look at this diagram, we can say B dash O is the image distance, BO is the object distance. But what is BF? We don't know what is BF. So what we have to do? We have to convert BF into the known terms. So from the figure, we can write BF is equal to, this is BF, is equal to what? BO minus OF. So BF is equal to BO minus OF. Also, B dash O dash is what? V. BO is what? Is the object distance and is taken in the direction opposite to the direction of light. So it is minus U. And OF is the focal length F. So our equation becomes, so with the B dash F, what we are going to write? I am going to write B dash F is equal to B dash O minus FO divided by OF or FO. Now substituting the value of B dash O, BO and FO, I will get, substituting the values of B dash O, BO and FO, we get V by minus U is equal to V minus F by F, or Vf is equal to minus UV plus UF. Now dividing the equation throughout with U, V and F. Dividing the above equation using U, V and F, and on rearranging we get 1 by F is equal to 1 by V minus 1 by u. The lens formula. Okay, so what was the step we used? We considered two sets of similar triangles, then we made certain approximation and we got the equation as 1 by f is equal to 1 by v minus 1 by u. Thank you.